There are multiple skill sets which are required for success and value derivation from data, right? So data scientists are at the core of the algorithm development, but that is not, like we saw earlier, that is not the only part of AI. We also need, we of course need data scientists who mostly develop the algorithms, the machine learning algorithms, and who come with a background in statistics, math, programming, and are comfortable with tools like Python, R, and SQL. But the infrastructure, like the cloud infrastructure, the ETL infrastructure around the algorithms, which are required actually for the development and deployment of the algorithms, that is where data engineers come into picture. So they come with a skill set in big data and cloud, and mostly take the decisions on the architecture, on how data needs to be stored, processed, and the analysis needs to be done, computed, etc. Right? So distributed computing, Python, cloud, these are mostly the skill sets of data engineers. And then we have data analysts, which are more like business analysts who translate the insights or the value from data into probably a suitable language that is consumed by any layman or the business users, right? So they mostly come with skill sets like SQL, Excel, and Tableau. Tableau, especially for data visualization and business intelligence. And then we have yet another very important aspect today, ML Ops. Now, ML Ops stands for Machine Learning Operations. Since we have seen that AI is being deployed extensively in real world systems today, so scaling up AI using ML Ops is very important. Now, what is ML Ops? It has basically three stages. ML design, where as per the crisp DM life cycle that we saw, it is to do with the first few stages in the life cycle, which are gathering the requirements, the business requirements, the data, and prioritizing the ML use cases, identifying the use cases, and also the data acquisition, which includes the extraction, transformation, and loading. And then we have the model development, which is the core algorithm development, the analysis. It could be a recommendation, it could be a classification application, it could be a regression kind of an application where we are predicting, it could be even forecasting. And all these would fall under the model development, which includes the training, testing, and evaluation of the machine learning models. And then we have operations, which is post deployment. So once we deploy the machine learning models in production in real world systems, like we said, we need to have the continuous training, a CI/CD pipeline, more like a one-click deployment of AI systems, the model monitoring, and making sure that as and when retraining is required, this is done automatically. Now, that is all about ML operations. So, yeah, AI is not a one-man army. Now, what do we mean by that, right? So, AI solution, the core may be the algorithm development and the deployment. But like we said, like we saw, the robust infrastructure and good quality data are as important as the algorithms themselves.